Okay, so we're on journal 17 here, and for this spell work, we're actually going to start out with some simplifying expression problems. As you can see here, there are factors, so this would be a factor, and there's a 5 in front. This would be a factor multiplied by this factor. So when we're multiplying factors, there's different types of situation, but the idea comes back to distribution. So like this 5 sits outside this parentheses, so we need to distribute the 5 inside the parentheses. So I'm going to go ahead and do that. So 5 times 6x gives me 30x. I just multiplied the coefficients. And then 5 times -1 is -5. And then we take a look if we can simplify any more, but x, 30x, and 5 are not like terms, so we can't combine them. So this is all that I can simplify it down to. And the x can also distribute inside, so x times x is actually x squared, or x to the second power. X times -4 is -4x. Now, if you have these two here, you actually can't combine them either. Even though they're both x's, this x is to the second power and this x is to the first power, so they are not like terms. In order to combine x's, they need to be the same power. So I'm just going to leave that as it is. I also like to mention to take a notice at x times x. So why is x times x x squared? Well, let's take a look at the exponents here. Notice how this exponent here, this x to the, just x itself is x to the first power technically, right? So it turns out when you multiply two things that have the same base, both of these have a base of x. Well, when you multiply both of these x's, you actually add the exponents. So in this case, if you have x, you take 1, add it with 1, add the exponents, and that's how they get x squared, or x to the second power. So now that I've mentioned that when you multiply two things of the same base, you add the exponents, these two are the same base, right? They're both x's. But this exponent here is x to the first power, so if you multiply, you add the exponents, so this is really x to the third power, right? Okay, because 1 plus 2 gives me 3. All right, now we got the big one here. So when we're multiplying this here, you might have seen it in Algebra 1, but basically what you want to do is take what's in one of the parentheses. So I usually like to start with this side, the furthest part to the left. So this parentheses here, I'm going to use my first term inside, which is the x. And what I'm going to do is distribute that x to the other parentheses, but I want to distribute that x to both of the terms inside the parentheses. Basically, just take the first term and multiply everything in the other parentheses. So that's why it's multiplying to both terms. So x times x gives you x squared. X times -4 is -4x. But then we have the -3 right here. So I've already multiplied with x. Now I get to use -3. So -3 times x is -3x. -3 times -4 gives me +12. Now when I pause here, I notice that I do have some like terms here, right? The middle terms, in this case, -4 and 3x combined to get -7x, and I'm going to bring down the other numbers. And now when I look at it here, it doesn't look like I have any more like terms, so that is my final answer. All right, so just kind of as a review here, when you distribute with two parentheses, make sure you distribute one term to everything in that parentheses one at a time, and then take the next term and distribute it to everything in the other parentheses. And we'll practice this more later on. But let's look at what we were learning in the last journal, and then we'll take a look at the new stuff. Okay, so here we have a problem that we were working on last time. So just to kind of review graphing in vertex form. So when you have in vertex form, you can see that the equation has parentheses, and outside the parentheses, there's an exponent squared, right? Because anything that's quadratic has a highest power of x squared. And so when we're graphing in vertex form, it's really nice to graph the vertex because we just look at the shift. So kind of as a quick reminder here, if you have just a general equation of a quadratic equation in vertex form. A negative means right. So a negative on the inside the parenthesis means right. A positive means left. If you have a positive on the outside, that means that it's going up. If you have a negative, that means it's going down. So in this case here, if you have a plus 3, right? A plus 3 is going to mean left 3, and then a minus 5 on the outside is going to mean down 5. So down 5. So we're going to go from the origin left 3 down 5, which is about right there, and I'm going to plot my vertex. And I'm going to put a V there to remember that that's the vertex. That's the middle part of the parabola. So this is -3, -5 for my vertex. Now here's the thing, when we draw a parabola, we want at least 3 coordinate points, so I still need 2 more. So what I do to try to get it is actually use the slope. So the slope is always a number next to the x, okay? Usually it's outside the parentheses, like this one. Here's the only caveat. When you use a slope for a parabola, you have to make sure the slope is over 1. The slope run is always 1. So in this case, my slope right now looks like 3/4. Here's the unfortunate part. This run here is not 1. Nope, it's not. So in this case, what we do, and what we can always do, is put that slope over 1. So this kind of looks weird at first because you have a fraction over, 1. But all you got to do is make this fraction into a decimal. So 3/4 as a decimal, or 3 divided by 4, is 0.75 for 1. So now I can see that my slope here is 0.5 and it's positive. So remember, this is rise, this is run. So in this case here, I actually go up about 0.5, which is almost 1, but not quite. So I go up about 3/4, and then I go to the right 1. And then I'm going to plot. So let me grab a marker here. There we go. And then I can connect the dots to make that U shape. But before I do that, let's go the other way to make this symmetrical. So you would go up 3/4 and then over 1 to the left this time. And then we're going to just connect the dots. So when you do this, notice how your vertex is a minimum. It's the lowest point on this curve. So we have a minimum. The axis of symmetry, well, it looks like it goes through x equals -3 for the axis of symmetry. So that's where your parabola cuts in half. So make sure that when you draw your line, that you're cutting through the x-axis. That's why it's x equals -3. All right, let's answer the domain and range first. So domain for all parabolas will always be all real numbers, right? Domains is talking about, how far does x point to the left and the x point to the right. So in this case, this has an arrow on the left and right, so I know it's going to keep moving to -infinity and +infinity on the x-axis. Now for the range, the lowest y value here is at -5. So I'm going to write that at -5. And the highest y value, because this parabola is pointing up, I know the highest point or y value is going to be infinity. And I need parentheses and then bracket on the -5. So when I'm looking for my y-intercept, let's just remember that the y-intercept relies on the y-axis. That's where all the x values are 0. So if x is equal to 0, we can find our y-intercept. So you don't use the graph to find your y-intercept, because most of the time when you draw your curve, it doesn't hit the y-axis, unfortunately. So what you have to do is you can find it by plugging in 0 into the equation and then finding y. So what that might look like is, let me do that here to the side. Oops. So we have 3/4, 0 plus 3 squared minus 5. If you were to work this out, remember to use order of operation. Please excuse my dear Aunt Sally, or parentheses, exponent, multiplication, division, adding, subtracting. So in this case, the first thing comes up is parentheses. So 0 plus 3 I need to take care of first, which would be 3. Exponents are next, so I have to square that 3. So that becomes a 9. And then at this point, if you want to type this into your calculator, you can. You can change 3/4 to a decimal if you want. But I'm actually going to just physically work that out by hand. So I can multiply 3 over 4 by 9 if I make 9 into a fraction by just putting it over 1. When you multiply fractions, you multiply the top with the top, bottom with the bottom. So 3 times 9 gives you 27 over 4 times 1, which is 4, minus 5. Okay, so at this point here, 27 over 4 is about 6.75. And then I'm subtracting that by 5. And so actually, let me double check if that's true. So 5 divided by, yeah, it's 6.75. And so if I subtract that by 5, you get 1.75 for my y value. So that means I need to go back and fill that in. Oops, sorry. I meant to write 7.75. So I found my y, and I think that's it. Let me just double check all my values here. 27. Yeah, I think we're good here. All right, so it looks like our y-intercept is 0, 1.75. So in the next slide here, we're going to talk about what it means to graph something called a standard form. All right, so here's the thing about standard form. So I want you for a moment not to focus on this f of x. So when we're graphing something in standard form, you will notice that there's an a, b, and c that is in standard form. Now, a, b, and c are not explicitly written when you see an equation that's in standard form, but what they represent is the coefficients. So the coefficients, or any coefficients, are numbers in front of a variable, like x squared or x to the first power, or sometimes they're just constants or numbers by themselves. So these letters represent coefficients, at least a, b, and c. And so another thing is that you don't see any parentheses here, right? Because this standard form, the disadvantage with standard form is that because there's no parentheses, you can't figure out the shift. And so that means you won't be able to use that trick where you shift the graph and then figure out your vertex. That's not what we do here for standard form. But there is some advantages here. So one of the things I like to mention is the c here. So c is the y-intercept. So that's the advantage with standard form, is that the c value, the number that's by itself, that's a constant, is the y-intercept. It just makes it a little bit easier to graph the y-intercept first. And another thing is that with quadratics, there's not a slope. So please, please, please do not confuse any of these coefficients as a slope. We're not going to use that as a slope. That's only when you have vertex form. So the thing we need to know is that when you have x, if you want to find the vertex, the x here comes with a formula. If you want to find x for the vertex, it is negative b over 2a. And I'm going to box this in because this formula is important. So basically, let's say you found you have your b value, you have your a value, you plug it in. Let me write that nicer so that way it looks actually like an a. And so when you plug it in, you'll find the number for x. And then so when you find x, what you got to do is plug that x value in for the equation where you see x's, and then find your y. So this would help you find y because f of x just means y. So once you find x, plug x into the equation to find y. All right, so what we're going to do is do an example problem doing graphing standard form. All right, so notice here we have an equation and there are no parentheses in this equation. So I know automatically that this would have to be in standard form because I can already see like the x squared, the x to the first power, the constants are all lined up in order by their greatest power. And I can kind of see the coefficients already. So standard form is when it's written in this type of format a squared plus b squared plus c, whatever a, b, c's ends up being some number. So in this case, my a here is 1. The coefficient in front of x squared is 1, technically. B here looks like positive 4. C here is negative 3. Now, if you remember before, I was saying that standard form, the advantages with standard form is that C is always your y-intercept. So we have a y-intercept at negative 3. So in this case here, if we were to plot that on our graph here, negative 3 is right here on the y-axis. So that's going to be 0, negative 3. And then we need to figure out well, we only have one point, right? And it's not the vertex. So let's go ahead and find that vertex. So a moment ago, I was saying that when you have a standard form, you need that vertex formula, x equals negative b over 2a. So in this case, we have negative b, which is, b is 4. So minus 4, 2 times a is 1. And so if I multiply this through, this is negative 4 divided by 2, which is negative 2. So x here is negative 2. So my vertex is negative 2 for x. I need to find y. So to find y, all I have to do is take this x value, plug it in for x's, wherever I see an x, and then find my y. So that might look like y equals negative 2 squared plus 4 times negative 2 minus 3. And if I work this out, negative 2 squared is positive 4. 4 times negative 2 is negative 8 minus 3. 4 minus 8 gives me negative 4. Minus 3 gives me negative 7. So in this case here, I have a vertex at negative 2, negative 7, which means I have to extend my coordinate system, but that's okay. So it looks like I have a vertex at negative 2, 7, which is about right here. So I'll put a little v here. So if this is my vertex, right, and I were to, draw my axis of symmetry, keep in mind the axis of symmetry goes through the vertex. So when I cut this parabola in half, notice how this coordinate here is 2, the y-intercept is about 2 units away from the axis of symmetry. So instead of going 2 units to the right, I'm going to go 2 units to the left, plot my point, and then graph my curve. So here's the thing. Because standard form doesn't give you a slope, okay, you can't find the point as easily. So what you can do is just plug in an x value. So the one that I recommend is just, use your y-intercept. Okay, so the y-intercept has to be when you connect the dots to the vertex, right? You only have one side of the parabola, so you can reflect it using the axis of symmetry. And this axis of symmetry here is negative 2. X is equal to negative 2. We can also see that we have a vertex that's in the bottom of this parabola, so that's a minimum. And then domain for all parabolas are all real numbers. Range here, the lowest y values at negative 7. The highest y value, there are arrows pointing up, so this is going to positive infinity. And negative 7 needs a bracket because it's a closed circle. All right, so that is it for this journal. In the next video, you'll notice that I'm going to try out a couple of problems from the homework, so stay tuned for that. Definitely look at the notes if you are curious now.